Today I want to talk about completing the square, and this is in the specific instance where you're taking a quadratic equation and putting it in vertex form. So just to clarify on that, when we have a quadratic, a lot of times we see it in this form right here, where a, b, and c are numbers. And then if we have it in vertex form, which I'll call g of x, the way we write that is a times x minus h squared plus k, where h and k are our vertex. So one of the ways to take the standard form and change it to vertex form is to use completing the square. Now, because this isn't us doing an equation, it's a little different maybe than the way we did it back in the day in Algebra 2. But it works very similarly, so I want to refresh all of our memories. So I've got 4 different problems for us to look at. Okay, I have here f of x equals x squared plus 10x plus 6. So the way I like to do this is I like to separate my x's from the number that doesn't have an x to start off with, because to complete the square, I'm trying to figure out what goes here so that I can write this parentheses as x plus something with a squared on the outside. That's why it's called completing the square. So I'm going to try to figure out what number to put here. But when I put a number here, it makes my equation unbalanced. I can't just add a number and not take care of a way to make it like I didn't add anything. So whatever I add here, I'm going to put the opposite sign on the outside of my parentheses. This is the same as in Algebra 2 when you were solving equations. You probably subtracted the number over to the other side. So that would make this really have like a negative 26 over here. And then you came up with what went here, and then you put the same thing on the other side. That's the same thing. So I'm going to try to work it out both ways, and you can decide which way you like better. Hint, hint, my way's better. But just kidding. Here we go. We always take the number that's in front of x, and we do our completing the square magic to it. Okay, which is we divide it by 2, always the number 2. You divide it by 2, and then you square your result. So through completing the square magic, I know I need to put a plus 25 here to be able to factor this into 2 parentheses that are the same. But if I put a plus 25 here, I need to put a minus 25 here. Okay, so now I'm ready to write my next step. And so x plus 10x plus 25, I can factor into 2 sets of parentheses where both of them are x plus 5. And I know that because 5 times 5 is 25, and 5 plus 5 is 10. I also know that because this number right here is always going to be the number that's in my parentheses. So if you remember that, then you don't necessarily have to think through the factoring part of that. Then I'm going to do the outside here. 26 minus 25 is a plus 1. Now I just need to write it with that parentheses as 1 parentheses squared plus 1. So now it's in vertex form, so I know that the vertex of this is negative 5, comma 1, because I change what's inside my parentheses. I change the sign, but the outside gets to keep the sign. Now let's look at how that changes if we're doing it this other way. I still do my 10 divided by 2 equals 5, and I square it and get 25. That stays the same, but since I'm adding 25 here, on the other side of my equation, I'm also adding 25, and I don't change the signs. It stays the same on both. So that gives me 25 minus 26 over here, so that's negative 1. Then I can factor this like I did before into x plus 5 times x plus 5. I want to now move the 1 over to the right side so that f of x is by itself. I also want to write this as x plus 5 squared and then plus 1. So you see we got the same answer for both, doing it either way. So pick which way you like better and go with it. Okay, example 2. Completing the square works really, really well whenever we just have x squared, but if we have something that's in front of x squared, it changes things up. So what we want to do is factor out of the x's, and only the x's, whatever it is that's in front of x squared. So for example, on here, I want to factor out the negative. So to do that, I had to take the negative away from the x squared and the negative away from the 12x. So I'm trying to figure out what to put here and here. Or if you're working out the other way, you should still end up with the same answer if you do it right. So I need to work my completing the square magic where I say, okay, 12 divided by 2 is 6, and 6 squared is 36. So I need to add 36 into my parentheses. Now, I added 36 to my parentheses, but really I put a negative 36 because that negative outside the parentheses, if I distribute it back, is a negative 36. Well, if I really subtracted 36 here, then to undo that on the outside, I need to do the opposite sign and add 36. Okay, so if you're doing it the other way, then you added the 39 over to this side probably. You still have to take out the negative. Okay, we still figure out, okay, I put a plus 36 here, and so I realize, hey, this is a negative 36, so you'd put a negative 36 on this side. Okay, so either way you want to do it is fine. Now I'm ready to finish completing the square. The negative stays on the outside. If I factor this into two parentheses, it's x plus 6 and x plus 6. So that's x plus 6 squared. Negative 39 plus 36 is negative 3. So not only do I know that my vertex here is negative 6 comma negative 3, I also know because of the negative that this opens down instead of opening up. If I finish this off over here, negative 36 plus 39 is 3. If I factor this, I get the x plus 6 squared, and then I just have to remember to subtract my 3 back over. Just kidding. Subtract my 3 just over there. Okay, so see, I got the same thing. Doing it either way, I just have to know which way I want to do it and then do it that way. If it has a number in front, then we have to factor out that number. Okay, so I would factor a 5 out on this one. So that gives me x squared plus 6x. I need to put something here. And then I need to cancel out whatever it is outside. So I work my magic. 6 divided by 2 gives me 3, and I square it, and that gives me 9. So I'm adding 9, but really I just added 45. So I need to subtract 45 on the outside. So that gives me f of x equals 5 times my parentheses has x plus 3 squared, because x plus 3 times x plus 3 gives me x squared plus 6x plus 9. And 50 minus 45 is 5. So that's my vertex form. Really the only thing that can make this more complicated is if we end up having to have fractions. So this last example has some fractions. And the reason is we're going to take out a 3 here. And if you notice, we don't have something in front of x that's divisible by 3 anymore. So we're going to get a fraction. So if I go ahead and work my magic, and I say, okay, negative 3 divided by 2, well, that's negative 3 halves. And if I square that, squaring a negative makes it go away, and I have to if I do 3/2 squared, that's squaring the top and the bottom, so that's 9/4. So I am adding 9/4 inside my parentheses. But what I really did to this side of my equation is I added 27/4, because 3 times 9/4 is 27/4. Well, if I'm adding 27/4 here, I need to subtract 27/4 over here. Okay, so on my next step, this is where it's really nice that I know that this right here is what's in my parentheses, because it's a lot harder to figure out how to factor x squared minus 3x plus 9/4 than it is if it was just regular numbers. So you can always look back to this number. This negative 3/2 is what goes in my parentheses. Now, whenever I come over here and have to work out 5 minus 27/4, this would be like 5/1. So I need to make it 20/4 minus 27/4, which means that I really have negative 7/4. So that would be my answer on that one. I hope this clears up some of our issues on completing this square in order to put things into vertex form.